Okay, so we are multiplying 2x cubed y to negative 3 times 2x to negative 1 times y to the third. Okay, so first I'm going to multiply the coefficients. 2 times 2 is 4. Okay, then I'm going to multiply x to the third times x to the negative 1. When you multiply things that have the same base, you're going to add the exponents. So x cubed times x to the negative 1, 3 plus negative 1 is 2. So this is x squared. And visually, if you want to think about x cubed times x to the negative 1, that's x times x times x. And then x to the negative 1, remember you send it to the denominator. So then the x in the numerator and the x in the denominator cancel each other out. And so then you'd be left with x squared. Okay, and then finally, we're going to do our y's. So y to the negative 3 times y to the positive 3. And if you multiply things of the same base, you add the exponents. So that's technically y to the 0. Negative 3 plus positive 3 is 0. Well, what is y to the 0 power? It's just 1. So this is 4x squared times 1, which is just 4x squared. So the negative 3 exponent and the positive 3 exponent actually cancel each other out. Okay, next one, 6. 4 times negative 3. I'm going to multiply the coefficients first, so negative 12. Then m to the negative 6th times m. Remember, this is m to the 1. When you multiply things that have the same base, you're going to add the exponents. Negative 6 plus 1 is negative 5, so it's m to the negative 5. And then k to the 7th times k to the 5th is k to the 12th. 7 plus 5 is 12. Okay, so the only problem with this is this m to the negative 5. That is our issue. We can't leave a negative exponent. So I'm going to keep the negative 12 in the numerator because that's totally fine. I'm going to keep k to the 12th in the numerator. And I'm just going to send m to the 5th to the denominator. That's the only thing that I have to move. Number 7, negative 5 x to the 6th, y to the 5th times z over 25 x to the negative 7th, y to the 3rd. Okay, take it one thing at a time. Start with the coefficients. Negative 5 over 25 reduces to negative 1/5. Okay, so if I'm thinking about my big giant fraction, I have a negative 1 in the numerator and a positive 5 in the denominator. X to the 6th divided by x to the negative 7th. I'm going to subtract the exponents. So 6 minus negative 7 is 6 plus 7. Think about it. You're going to bring x to the negative 7th. You're going to bring it from the denominator up to the numerator. It's going to come up and join x to the 6th in the numerator. So now it's going to be x to the 6th times x to the 7th. So you're going to add the exponents, 6 plus 7, to get x to the 13th. So in the numerator, you're going to have x to the 13th. And again, remember, if you're dividing x to the 6th divided by x to the negative 7th, you're going to subtract those exponents. So it's 6 minus negative 7, which is 6 plus 7, which is 13. Okay, and then we're going to do the same thing with our y's. Y to the 5th divided by y to the 3rd. You're going to subtract those exponents. Y to the 5th divided by y to the 3rd. 5 minus 3 is y squared. 5 minus 3 is 2. And then the z is just chilling in the numerator. There's no z in the denominator. And so your final answer is just going to be negative x to the 13th, y squared z over 5. You can technically write the 1, but you don't have to. Okay, number 8, 4xy, all of that to the negative 1 power. over 5z to the negative 6th. Okay, so since you're putting this whole thing in parentheses, this whole entire thing is getting raised to the negative 1 power. So I'm going to send that whole entire thing to the denominator to get rid of that negative exponent. So that's going to be 4xy to the positive 1. Because I just need to switch it from negative 1 to positive 1 as the exponent, so I'm just going to send it to the denominator. Okay, then the 5 is totally fine in the denominator, so I'm going to leave the 5 in the denominator. And then the last thing I need to do is I need to get rid of that z to the negative 6th that's in the denominator, so I'm going to send it to the numerator. So it's going to make it positive, so it's going to become z to the positive 6th. So then I don't need this 1 or this parentheses, technically, because I'm just raising it to the first power. And so I'm just going to multiply our coefficients 4 and 5 to get 20xy, and then in the numerator is z to the 6th. So your final answer is z to the 6th over 20xy. Last example is cuckoo, bananas, crazy, but that's okay. Okay, so first off, we have a 3. That's our only coefficient. It can hold down the fort and the numerator. Okay, for our x's, we have x to the 3rd divided by x to the negative 4th. X to the 3rd divided by x to the negative 4th, which is, you're going to subtract the exponent. So it's x to the 3 minus negative 4, which is x to the 3 plus 4, which is x to the 7th. So in the numerator, you'll have x to the 7th. Okay, then let's do our y's. Well, this is, if you want to, you can think of this as technically this is just 1. Y to the 0 is 1, and z to the 0 is also 1. So those are just irrelevant now because it's just 1. So now I can focus on taking care of this negative exponent. Y to the negative 1, I just need to send it to the denominator to make it y to the positive 1. And then same thing with my z. Z to the negative 1, I just need to make it positive, so I'm going to send it to the denominator, z to the positive 1. And then to just make it nice and official and beautiful, I don't need those exponents of 1 because y to the first power is just y. So I'll rewrite it as 3 to the 7th over yz.